Hello guys, a very happy morning to every one of you. Guys, today we are just going to start one of the interesting subjects that is called as industrial engineering. So why this subject is so much important is because it gives it how to say means very advantage, okay? Because this subject around currently holds about 6 to 7 marks in the gate point of view, and such a easy scoring subject this one is. So that's why. So you want to just see each and everything in the subject, okay? So the first chapter literally covers about nearly 6 to 7 chapters mainly, especially in the how to say means each and everything. So without wasting time, let's get started. Okay. So sometimes you might have any kind of confusion that whether this subject will go for so much long duration. So like that also. But while you are just going to see this subject each and every way, you will have a clear cut understanding of each and every perspective. Okay. So without wasting time, let's get started. Okay. So you can see here first what is I have just given inventory control. So you can see inventory is defined as any ideal resource of an enterprise. It is physical stock of a goods kept for future. Okay. So such a simple thing. So before going into the stores, it means before you are going to department store means the product should be available before it's okay. So that's why the stock should be kept ready, okay, for future use. And you can see inventory may be raw materials, semi-finished parts, and simple furniture machinery. And inventory is a stock in hand to meet unforeseen demand. Suppose in future if the demand is so much high means they should be so much peculiar to correct that one, okay. So you can see too much of inventory is also sign of inefficiency, because if no goods is been running means no one is buying our product means it is waste, okay. It is too much of inventory, it's no sign of no use, okay. So next one you can see it means the types of inventory. Raw materials, yes, definitely, and bought out parts, work in process, semi-finished product. Suppose you can see the it means for example you can take the example of tea. So when a customer comes, instantly you are giving the tea or the tea process is going on. The tea process will be for 2 to 3 minutes, and after 2 to 3 minutes you are just delivering the tea to him, okay. Like that similar process also work in process, semi-finished inventory, okay. Next one is finished goods product. For example, he just asks a biscuit, so will you make the biscuit and will you give? No, already finished biscuit only you will give, okay. Next one is indirect inventory. So normally they do not form, okay, final product but consumed in the production, okay. I think so you can understand. It's not, it means how to say means for making the biscuit, what you will use, you the oil, wheat, this kind of things comes under this. For the making of tea, what you will use, milk, tea powder, and tea, like the kind of extras and like that. So miscellaneous inventory is office. For example, if you just take tea means whether you will just pour with in their hands, or whether you will just give a glass to and in the glass you will just pour and give. So this kind of glasses are miscellaneous inventory, okay. So basic thing. So next you can say reason for maintaining inventory. 2, it means tea powder, the milk, the biscuits, and each and everything in the form we should maintain, okay, to ensure smooth and effective, efficient running of business, to provide adequate service to customers, to avoid shortage, to meet unexpected demands, to take advantage of price discount. Usually manufacturer offers discount for bulk buying and goods, okay. Suppose if they buy bulk means they'll give extra. Suppose if we just go and buy tea coffee for 20 to 30 members means they'll just give extra tea, okay. That's it. To gain this price advantage, the material bought in bulk, even though it is not required immediately, okay. Suppose sometimes you can see the materials is bought in bulk quantity, means bulk quantity, so for future demand, okay. Suppose tomorrow rainy season is going to occur means most of the peoples will just buy lot of essential item before result, so like that, okay. I think so you can understand. Cost associated with inventory, so unit cost or item cost, okay. Unit cost or item cost means per head cost, it means one item cost or one unit cost, like that, okay. So next one is order cost, okay. Ordering cost, it means for Amazon, Flipkart, ordering cost, okay. People, transport, ordering cost is independent of size of order, okay. Suppose you may order 10 books or 20 books, but the order price is same, okay. Next one you can see in this order cost as well, inspection check is there, quality check is there, rejection check is there. Suppose if you just rejected means you won't get the second required amount, and delay cost is there, follow up cost, okay. You can see follow up cost means 80 items we said and I need on Monday, but he did not give on Monday. Suppose you can see if I just tell okay, I think so you can understand. So I just need the required items in Monday means he did not he told okay, I am not able to send it on Monday, so you just I have the each and every goods, but Tuesday will take it. So what you will do, see, we will make a person to go there, and we will make the person to buy the required product. Okay, that's the thing called follow-up cost. Next one, holding or carrying cost. So why this is important means, for example, you can see this one. How to say means, suppose you can see in a bakery, it is take here pups and bonda, samosas is being there. Okay, but here fully water bottle is there, full of water bottle. So the shelf size same and each and everything is same, but you can see in this sector, each and for within 3 to 4 hours everything the rack fills, it means the rack becomes empty. Okay, by this how much product we are getting? We are getting 1000 rupees, but you can see it is entirely a water bottle. How many person will come there and buy the water bottle? Per day one. Okay, per day we are getting 15 rupees, but this is for 1 hour we are just getting 1000 rupees, means we just multiply into 10 hours, so 10,000 rupees we are getting by this pubs bonda each and every. But by this you can see, but one day for 24 hours they are just getting one, it means 15 rupees. So you can see for which one holding cost is so much, for this one holding cost is so much, but for this one holding cost is less, because within small amount of time it's been sold. Okay, this is called as, okay, I think so you can answer holding cost or carrying cost. Suppose you can see space rental, because per month we give rent, that also comes under holding cost. Power, yes, power also holding cost. And absolute items, suppose you can see if sometimes we do keep the kind of things in our shops, and suddenly the government bans it. Okay, allowing blacks. Okay, I think so. Next one is pilferage. Okay, pilferage means suppose items is been stolen. Okay, next one is cost of capital, insurance, taxes, CCTVs, damage cost. So you can see CC, holding cost per unit per time. Okay, holding cost per unit per time. Okay, next one is shortages, back order cost. So loss of profit, lost sale, loss of opportunity, underutilization, shortage occurs. So I send a person to do the work. Okay, rescheduling again and again, the process is being rescheduled, additional cost, figure cost, and loss of customer goodwill. So okay, suppose I just ordered lot of clothes. So in Deepavali first day if it comes in, it's okay, or the Deepavali last day comes, it's okay. Deepavali first day is okay, so like that. Okay, so next one is, in this itself there are two type of model. Okay, inventory model, deterministic model, probabilistic model. Probability means just an assumption, tomorrow like this happen, tomorrow it won't happen, like that. So deterministic model means demand is known. Okay, and it is certain. Suppose how to say means, if a person orders 10 books and we know the demand and we know the how much certain is that, but even now only I'm just writing a new book. Okay, whether the book will sell or no, I don't know. Whether the book will just go profitable or unprofitable, I don't know. So that comes in a category of probabilistic method. Okay, so mostly our theory holds upon Wilson and Harrison model. Okay, basic inventory model, purchase model, Wilson and Harrison model. Okay, so you can see here demand is uniform. So it means per day I need 10, means so for the 30 days I need 10 only. Okay, unit. So the next is, you can see demand is uniform, unit cost. Okay, so okay, unit cost is of an item is constant. Suppose for example unit cost is 10 rupees, means 10 rupees same. Okay, lead time 0. Okay, lead time 0 means you can see the placing of order and receiving of order is same. Okay, for example if you just order in the Amazon, how much days it will take? It will take certain amount of days. Okay, maybe it means 4-5 days like that, but this time I'm ordering at 10 o'clock, means at 10 o'clock 0.0001 itself the order has been placed. Okay, so instantaneous replacement. Okay, replenishment. Okay, so no buffer or so it means so each and everything very much quickly, no buffer or everything is in the safety cost. Okay, no shortage. Okay, cycle time is fixed or same. Okay, so next we can just see, so D is the annual demand or demand per year. Okay? D is the demand per year. Okay, so you can see demand per year with respect to time. You can see this is the quantity, this is time. Okay, this is quantity, this is time. Okay, this is the slope equal to demand per year. Okay, total demand per year. Okay? So let us assume for an item annual demand is 12,000 per year. So you can see consumption 12,000, then per year the per month 1000 we need. Okay, I think so you can understand. So, okay, so suppose if we just made in a different way, So number of order you can just see n equal to 3 per it means per 4 month I'm ordering means you can see split into 4. So you can see n is number of order. Okay, suppose you can see if n equal to 1 means you can see ordering cost is very much low. It means ordering cost is, for example, n equal to 1 means 100 rupees is very much low, but you can see the holding cost, we need to hold the amount for a certain amount of duration, then holding cost increases. The same thing we need just increase n equal to 4, you can see rupees is 400, for example. It means 4 times, it means 3 months 1 year ordering means 3 months once 100 rupees, so 4 times is 400 rupees, but holding cost is so much lesser. Okay, you can see whenever the ordering cost increases, the holding cost decreases. Okay, this is a basic principle. So number of order are less, ordering cost is less, but holding cost is more. So we place, it means we also place a minimum amount of order and as well as the minimum amount of holding cost. Okay, so total variable cost equal to ordering cost plus of holding cost. Okay, so total variable cost is ordering cost plus of holding cost. Okay, this total variable cost. Okay, this is total inventory cost, it means at almost total. So total inventory cost is item cost. Okay, item cost plus total variable cost. So now you can see this is cycle time, means for 4 months you are just starting 4000 is the first cycle time, 4 months, and you can see demand is constant. This is the demand is constant. No, it means like instead of going like this, demand is constant. Okay, so D is the annual demand per year, and Q is the quantity. So number of order equal to demand per quantity. Okay, so you can see demand is 12,000, but quantity we are ordering is how much? Q is 4,000. You can see only 3 times you are ordering. Okay, next one CC is ordering cost. Ordering cost or cost per order. Okay, so total ordering cost equal to number of orders, it means per year, into ordering cost. Okay, so total ordering cost is number of orders per year divided by carrying cost. Okay, I think so you can understand. So number of orders into C naught. Okay, n is what? D divided by Q equal to C naught. Okay, next one is CC. CC is holding or carrying cost. Okay, CC is holding or carrying cost per unit per time. Okay, so in this mostly we need to take only Q average. Okay, this is the graph I think so, and so we just see the this one. Okay, I think so can answer. So Q average equal to cycle area divided by cycle time. So cycle time is T. Okay, this is T. So what is the, it means area 1 by 2 Q, this is T. Okay, Q divided by T divided by cycle is T. Okay, so T cancel, so Q average is Q divided by 2. Okay, so total carrying cost is CC into Q of average. Okay, equal to CC into Q divided by 2, total ordering cost. Okay, so total variable cost is total, it means total ordering cost per total carrying capacity. So total ordering cost is D divided by Q into of C naught plus of this one, CC into Q divided by 2. Okay, this is total variable cost. Okay, I think so you can understand. So you can see now the total inventory cost is this one, D into, it means I think so you can understand. So demand into cost of per item. Okay, this one total variable. So for minimum total cost, what we can just vary, only total varying cost with respect to DQ alone we can vary. Okay, it means total cost divided by DQ equal to 0 means just a difference. So what will come, this one will just go, so minus D by Q square C naught plus of CC divided by 2 equal to 0. So while you just put what will be the Q value, Q equal to root of 2D C naught of C3. Okay, okay, Q equal to 2D C naught of CC. This is economic order quantity. So in this quantity if you order means it will be so much good thing. Okay, economic order quantity, it is such a quantity where the total cost is optimum, or minimum. Okay, So ordering cost is d divided by q of c naught, holding cost is q divided by 2 of cc, economic order quantity root of 2d c naught of cc. Okay, so next one, ordering cost and optimum condition, you can see for minimum cost. Okay, so what will be the minimum cost? So what I just told, ordering cost is d divided by q of c naught. Okay, this q dash, this economic order quantity equal to q dash. So d divided by q dash of c naught. Okay, just go and multiply. We will just order equals ordering cost equal to, how to say it? Okay, we can write like this. Okay, root of d c naught of cc divided by 2, or 1 by root 2 root of d c naught of cc. Okay, so next one is at optimum condition, ordering cost and holding cost are same. Okay, it means at optimum condition, ordering cost equal to holding cost, okay, are same. So you can see if your total variable cost optimum condition is 1 by root 2 root of, it means d c naught of cc plus, it means you can say holding cost also same. Okay, 1 by root 2 root of d of c naught of cc. So what will be the thing? Total variable cost for minimum is root of 2 d c naught of cc. Okay, that's it. I think so you can understand. So now total minimum cost is demand into c into plus of root of 2 d c naught of cc. Okay, total minimum cost. I think so you can understand. So you can see ordering cost equal to d divided by q of c naught. Okay, you can see ordering cost generally represented the y axis and the q represents the x axis. Okay, you can see ordering cost equal to dt of c naught divided by q. Okay, ordering cost into q equal to constant. Okay, you can see this entire term is rectangular hyperbola. Okay, it is rectangular hyperbola. I think so you can understand. But the most important thing is the holding cost. Holding cost is quite different. So you can see q divided by 2 c naught cc. Okay, you can see this entire thing is linear. Okay, y equal to x into m. Okay, this thing. Okay, so this is straight line. So graph will be like this. Okay, the rectangular hyperbola will be like this. So you can see this is q economical. Okay, economic order quantity. Okay, this is holding cost, this is ordering cost. So this is entire thing is represent cost, this one is a quantity. Okay, I think so you are getting the point very much clear. Super. So let's go for next thing. So you can see this one. So you can see what is this one? Total, this is holding cost. Okay, you can see this one is ordering cost. Okay, so this one is total variable cost. Okay, but when you just go, you can see this is the total cost. Okay, this is total variable cost, this is total cost. Okay, and suppose if we just come in this side, means you can see here what is the thing. So here ordering cost is, you can see just plot a line. Here ordering cost is so much higher when we compare to the holding cost. When we just go this side, you can see here the holding cost is so much higher. When you go here, ordering cost is so much less. You can see holding cost, this is ordering cost. So you can see at this one, the ordering cost of the minimum, the holding cost of the minimum. Okay, at this one. So we need to just find this one. Okay, what I just told, the ordering cost, holding cost equal to root of d c dot cc divided by 2. Okay, okay. So you can see if q dash less than means, you can see this one. So next one, sensitivity of the curve at EOQ. Okay, now we are just comparing the normal thing with respect to the EOQ. Okay, it means no minimum. So one thing TBC, it means total variable cost divided by TBC at a minimum condition. So before thing, what is just d divided by q of c naught. Okay, plus of q average divided by 2 of cc divided by root of 2d c naught of cc. So economic order quantity equal to root of 2d c naught by cc. Cc will be at the bottom. So this c naught will come up when this one. Okay, total variable cost. I think so you got the point. So now we just took this one and how to say this, d divided by q c dot root of 2d c naught of cc, root of 2d c naught of cc. Okay, like that you just need to separate and we need to just proceed upon. So while you are just pressing TBC divided by TBC dash equal to 1 by 2 Q dash divided by Q plus of Q divided by Q dash. Okay, this is the basic equation. Okay, so you can see this total variable cost and there will be total variable minimum 1 by 2 Q dash divided by Q. Okay, I think so. It's such a easy question only, so don't need to confuse yourself. So before seeing into the problems, let us go to the next thing. So this is the second question. Okay, so inventory problem, inventory model with the shortage. Okay, suppose if the inventory model with the shortage or back order. Okay, so you can see now the shortage has been occurred. Okay, so how much process will be delayed? We can see this is the inventory control. Okay, so same you can see it is goes down like this and goes like. So now again the demand rises and again the demand is continuing. Okay, so you can see this entire thing is shortage. Okay, this one is T1, this one is T2. Okay, so you can see how much quantity we needed. Not this much quantity we need, but what we have, this much quantity only we had. So this one goes to the shortage. Okay, so I think so you can understand. So you can see this is IM. Okay, this entire thing is IM. So this is yes. This is what slope demand per year. Okay, this one is T1, this one is T2. This entire thing is total time. Okay, I think so you can understand. So total cycle time T equal to T1 plus of T2. Okay, so demand equal to this IM, this one entire thing will come, but it means two things will come here. I'll just explain to you. Okay, first you will just take the one of the basic thing. Okay, demand equal to this one general thing means the entire Q divided by T1, Q divided by T1 plus of T2, but this divides into D equal to Q divided by T1 plus Q divided by T2. Okay, so you can see this D equal to this entire thing is this one. Okay, so IM plus of T1, this one S plus of T2. Okay, I think so you can understand. So this is D equal to S divided by T2, this D equal to IM of T1. Okay, just put here and you can just calculate easily. Okay, sometimes the demand equal to Q divided by T1 plus of T2 also we can just write. So you can see total cost equal to item cost plus ordering cost plus holding cost plus shortage cost. Okay, shortage cost we need to just include. Okay, here ordering, it means here total item cost plus ordering cost plus holding cost plus a shortage cost. Okay, so next is one of the most important thing is here this triangle. Okay, I think so you understand. This is IM, this is shortage cost, this is T1, this is T2. Okay, this is theta, this is theta, and I think so you can easily do it. Okay, this one Q, it means theta, tan theta equal to Q. So this one is the IM divided by T1, this one is S divided by T2 equal to total is how much? Q divided by T1 plus of T2. Okay, total T. Okay, this is the main thing. Based upon this also we can just calculate each and every answers. Okay, so you can see holding cost and carrying. You can see this is the holding, because this doesn't come under holding because we don't have enough items here. So you can see IM of T1, this is the, it means holding cost and carrying cost, each and everything comes here. Okay, just 1 second. I think so now you are able to see this one. Okay, Okay, so now you can see holding costs are carrying cost. This is so Q average of area of cycle divided by cycle time. So area of cycle is one, but the cycle time is total T. Okay, so that's why we need to take this one. Okay, I think so got the point. Okay, 1 by 2 IF of T1 plus 0 into T2. Okay, you can also put 1 by 2 into yes, but yes, we don't get. Okay, because it is shortage. Okay, so IM T1 divided by 2 times of T. Okay, so holding cost is CC into IM T1 of T divided by T2. Okay, so 2T. So next one you can see shortage cost. So due to the shortage cost also we just lost a little bit of quantities. Okay, so you can see shortage cost is equal to, for shortage cost we don't consider the above one. So both are different triangles that are being placed. One is placed above, another one is placed below. Okay, so you can see the shortage cost for this one is Q into T1 plus of 1 by 2 T2 into S. Okay, divided by T into CS. Okay, shortage cost. So you can see this one, it means shortage cost equal to S T2 divided by 2 times of T into CS. Okay, so total variable cost equal to ordering cost plus of holding cost plus of shortage cost. Okay, the entire things. Okay, so I think so you can understand, guys. So while you just put T1 of T equal to IM of Q and the T2 of T is S of Q. Okay, based upon the before thing we just taken. So total variable cost is entirely this thing. So total variable cost equal to D C naught of Q. This one is ordering cost plus of holding cost IM square CS divided by Q CC plus 2 plus S square CS of shortage cost 2 times of Q. Okay, so for this it means minimum quantity also we need to take. So just differentiate with respect to, it means two things will come. Okay, you can see here. So here two variables is there, so we need to convert the two variable into single variable, and after that we need to differentiate it. Okay, so you can see this entire thing now be converted to single variable. Okay, well you just calculate, you can see S equal to Q CC divided by CC of plus of CS. Okay, this is the number of shortage permissible minimum cost. Okay, shortage for minimum cost is S equal to Q CC divided by CC of plus of CS. Okay, while you just make DQ is equal to 0, you can see this thing will come. And what will be the final answer? This is the economic order quantity with the shortage. Okay, economic order quantity with the shortage out of 2D C naught of CC CC plus of CS divided by CS. Okay, economic order quantity with shortage. Okay, I think so got the point. So next one you can see total variable cost. Okay, so while you just total variable cost or minimum, you can see this one. So what will be the thing here? The total variable cost for minimum, say T divided by Q of C naught plus of Q divided by 2. Okay, this holding cost let us consider it's like a triangle. So divided by CC plus of CS, upper one CC of CS. Okay, it's the basic thing I just wanted to tell you. Okay, so whenever you just put this thing, it means Q dash the Q, you get to see this Q dash is here at here, you can see this right here, this comes. Okay, so that is the which one total variable cost for minimum. So you can see when shortage are permitted at DOQ, ordering cost is equal to holding cost. Ordering cost equal to holding cost plus shortage cost. So again, when order, it means when shortage are permitted, so you can see ordering cost is equal to holding cost plus shortage cost. When shortage is permitted DOQ, ordering cost equal to shortage cost plus holding cost. Okay, so you can see total minimum cost is root of 2D C naught of CC into CS divided by CC plus of CS. Okay, economic order quantity with the shortage and without shortage and with shortage. Q dash equal to 2D C naught of CC. Okay, so this is economic order quantity with shortage. Q dash equal to root of 2D C naught of CC into bracket of CC plus CS divided by CS. Okay, so next thing you can see total variable cost 2D C naught of CC, but total variable cost you can see everything is same, CS divided by CS plus CC. Okay, so next one you can see CC plus CS will be CS greater than 1, okay, or CS divided by CC plus of CS less than 1, okay. You can see Q dash without shortage is greater than Q dash with shortage, okay. So you can order, it means you can order more of the quantities with the shortage, okay, not without shortage. So, and you can see in this side total variable cost is maximum without shortage and total variable cost is minimum with shortage, okay. I think so you can understand. So you can see so Q dash without shortage is this one, Q dash with shortage is this one. So I will just write a reference forward. You can see when cost of shortage, when cost of shortage is infinite, CS is infinite, you can see this one. So this entire term goes to 1, and you can see we just bought to the first model, okay. So sometimes we appreciate shortage and sometimes we don't appreciate shortage, okay. So next one you can see production consumption model, okay. In production consumption model, so the next thing you can see the production and consumption model. So you can see this is quantity, and I think so you would have known about this one. So just 1 second. So I'll explain this and we'll just finish up the chapter. So production consumption shortage. Maybe I just need only 2 classes to finish this, okay. Just it's entirely theory, okay, that's it. So you can see production and consumption model. So it's like a tea manufacturing and coffee manufacturing. So one side they have been producing and another side they are using, that's it, okay. So wait 1 second. Okay, so you can see here the production rate must be greater. If the consumption rate is so much higher, means we will face a lot of issues, okay. So the production rate need to be so much higher, okay. So you can see production and the consumption, production plus the consumption model, okay. This is the entire graph. So one side is full of production, okay, while it's been producing the consumption is also so much higher, okay. So I think so you can understand. So this is the demand needed, okay. This entire thing is demand. So for this demand they are just producing it, okay. It means how to say, means so for example I'll just write the here, okay. So you can see they are producing this much, okay. Suppose they are producing 100, so no consumption, it means no money is consuming. But you can see if they are consuming 50, means whether it will be same like this, it will be like this, okay. This is entirely P, this is P minus of D, okay. This is 50, okay. The same thing, the graph goes like the same production goes like this, but the same like this it goes, okay. I think so you can understand, just a basic thing only, okay. The same thing goes for here, like this production and like this is in consumption. This one is production minus of consumption, okay. Margin minus demand, this one is production, so okay. So I think so you're getting the point, okay. So you can see this is a Q, this is a total, this is the entire ordered quantity, and P is the production rate, and IM is the maximum inventory, okay. So this is a Q and this is a production, this is the inventory management, okay. P minus FC. So guys, you can see it means I'm just how to say, means for example I'm just producing 100 pups, it means 100 samosas, okay. 100 samosa, it means I'm just manufactured here. This is a place for holding 50 samosa, okay. This is a 100, but I have 100 samosa. Here the 50 customers are waiting to eat one samosa. So 100 samosa I just manufactured, 100 goes here, it means 50 goes here, 50 goes to the hand of customer. So you can see for this 50 only I will have the holding cost, but for this 50 I won't have any kind of holding cost because it directly goes to the consumer, okay. That's a simple logic here, okay. I think so you can understand. So you can see what is the principal equal to this one q divided by time, okay, because the slope is constant, okay, the slope is so q equal to p into t1, okay. So how we can just write the demand equal to q divided by t, okay. So q equal to demand into time, okay. So you can see this, while you just put here t of time, you can see about the im is inventory management about the first step. So d minus of p minus of d of t1 equal to I of m, okay. Next one for t2 you can see im divided by t2 equal to d equal to d, okay. Im equal to d of t2. So you can see how much equation you are just getting, 1 2 3 4 equation you are getting. So from equation you can see im divided by q equal to p minus d of p of t1, okay. So for cycle im equal to q p minus d into t into p, okay. So im divided by q equal to p minus of d divided by p t1 of t1, okay. Im equal to q p minus of d divided by p, okay. I think so got the point. So here no ordering cost will be produced and consumed. Oh wow, I think so you can understand. Here no ordering cost is there. Holding cost only will be become 50%. So no shortage will be, okay. So you can see setup cost. So d divided by q of c naught, okay. Setup cost is our thing, okay. And holding cost, because 50 samosa is holding, so holding cost. Next one item cost, okay. Item cost is fixed, okay. So this only goes to setup cost, okay, that's it. Okay, total variable cost is setup cost plus of holding cost, okay. Setup cost one, suppose if we are just going to the 50 samosa to the customer, means who should give? Directly from where it will come and place in our hand? No. So we have to place a person there, and by placing the person we need to give the any kind of salary to him. So that also comes as setup cost, okay. D divided by 2 d divided by q of c naught, okay. Setup cost for one setup, okay. So q average equal to, you can see 1 by 2 im of t divided by t, okay. Im divided by 2, okay. This is holding cost and this one is inventory cost, entire thing, okay. So we'll just differentiating that q dash is this one. Wow, you can see root of 2d c naught divided by cc p minus p divided by p minus of d, okay. This is the entire thing, okay. Total variable cost is setup cost plus of holding cost, okay. So when you just put the optimum minimum at the economic order condition, setup cost goes equal to holding cost, okay. So total variable cost of minimum is root of 2d c naught of cc bracket of p minus d divided by p, okay. Root of 2d c naught of cc root of p minus d of p, okay. I think so we are getting this point. So just a basic thing. So this is just a explanation, because these are just problems. So problems I will just explain you later on. So next thing you can see production and consumption with the shortage. Suppose if it's been occurred with the shortage, mean this kind of problem will come, okay. So I'll just tell this thing later on, okay. So until then, take care, bye bye, have a good day guys.